let's take a look at another CSCS sorting and searching problem. Towers. So what's going on here? We have n cubes in some order, and we want to build towers with them. And you can only place a cube on top if it is strictly smaller. So we have to process them in the order that they're given. And you can either place the new cube on top, right, if it's smaller, or we can start a new tower. And you want to find the minimum number of towers. So for example, here, the 3 starts a new tower. There's no existing towers. 8 also has to start a new tower because it can't go on top of 3. 2 could go on top of 3, 1 could go on top of 2, and then 5 could go on top of 8. So in total, we could do 2 towers, which is the minimum possible. So that's the answer here. So we have up to 200,000, up to a billion units high. So actually, this is we can do just a greedy strategy. So you always want to put the new block on top of the biggest tower that it fits on. And if it doesn't fit on anything, then you have to start a new tower. And so why is that? Well, so starting a new tower, basically, that leaves you in the best possible position, like a strictly dominant position. Starting a new tower, you could always, put this guy on a block now and then start a new tower later and be in a better position. It gives you more flexibility. And you always want the current tops of your towers to be as big as possible so that you can put the most stuff on them. So if you put a new block on a tower that's as small as possible, that gives you the most flexibility, right? Like when we're putting down the 2, we want to put the 2 onto the 3 instead of the 2 onto the 8. Either way, we're going to have a tower with a 2 on top, but we'd rather have an 8 available than have a 3 available. And in fact, we need that, right? We want to put the 5 on the 8 later. Yeah, so we just need to be able to look up, right, so we want to put each block on the smallest thing that is bigger than it. So if we might have a linear number of towers, right, if things keep on getting bigger. And so we can't just scan them all every time. That would be n squared, right? Every time we place a block and there's n blocks, we might have to scan n towers. That's n squared, that's too slow. But actually, this is like a set query, right? We just want to, we have a list of numbers, which is the heights of our towers, and we want to find the smallest number that's bigger than something. So we can use sets upper bound, right? Upper bound gives you the smallest thing that is bigger. Not that one, but this one. Right, first thing that goes after. Yeah, so let's do that. I first find the API for upper bound to be rather confusing. I have to look it up every time. Okay, so we get a new value, and we're going to have a multi-set of our current towers, right? It should be a multi-set because you might have 2 towers of the same size, of the same top cube. There's nothing about the sizes being distinct. I find this name very confusing. Anyway, the first thing is bigger, so if there's nothing bigger, then we have to start a new tower. Otherwise, we can add this x to multi-set, and at the end, we just print out how many towers we need. The usual includes. in region n. Okay, that gives us 2. That's a good sign. Okay, so it works. So yeah, we're just doing this greedy approach that I talked about. And the key thing is this call to upper bound. As I say, I personally find this API very confusing. I have to look it up every time I want to use it. But it returns the first element, which is strictly bigger. Lower bound gives you greater than or equal to, I believe. So we want strictly bigger here. And if it's s.n, that means it didn't find it. And then we start a new tower of known size x. And otherwise, we put x on top of the tower. So s is supposed to be the tops of the towers. So the old top is not a top anymore, right? It's the second thing. So we get rid of it, and then we throw an x. So either way we throw an x. It's just a question of whether or not we erase something. And these are the tops of the towers, so we just want to know how many of them we have, so we can add s.size. That's the problem.